Using ethylene inhibitors to extend the shelf life of turf-type tall fescue sod. This research project was led by Dr. Xinjiang Zhang. It was supported by myself, Mike Goatley, and John Dickerson. Sod quality declines pretty rapidly after harvest. During transportation, and the longer it sits on a pallet, the less likely you are to have a successful sod establishment. It's a naturally occurring process. The plant hormone ethylene is associated with leaf senescence. What this project was attempting to do was to somewhat reduce that rate of leaf senescence, the heating that naturally occurs on this pallet. The floriculture industry has done something similar for many years now. They extend the life of cut flowers by making a post-harvest treatment with an ethylene inhibitor called 1-MCP. Its trade name is Ethylblock. Dr. Zhang's literature review also uncovered two other potential ethylene biosynthesis inhibiting compounds, one called AVG, amino ethoxyvinyl glycine, the other one a polyamine compound called spermidine, SPE. Both of these compounds have been shown to delay senescence and inhibit ethylene biosynthesis. Our objectives were to evaluate the effects of Ethylblock, AVG, and SPE, either alone or in combination. We wanted to look at them and their effects on ethylene production within the sod roll, the heat that occurred within the sod roll, and the shelf life out in the field of a turf-type tall fescue sod in relation to its visual turf quality and its rooting. We took a mature tall fescue sod at the Turfgrass Research Center of Virginia Tech. It was maintained at 2.5 inches. It's approximately 3 years old since it was established. It receives 2.5 pounds of nitrogen per 1,000 square feet per year. We installed a randomized complete block design with 8 treatments and 4 applications. The AVG and SPE treatments were applied 48 hours before sod harvest using a CO2-powered bicycle boom sprayer. The Ethylblock was applied immediately before sod harvest. Here's what the treatments look like. Number 1 is the negative control, which nothing was done except for the harvest itself. 2, 3, and 4 were the ethylene biosynthesis inhibitors, and then we look at the various combinations of those ethylene inhibitors to see if there were any synergistic, additive, or possibly antagonistic effects. On the left is Dr. Zhang applying the AVG and SPE treatments, 1 gallon solution per 1,000 square feet. These treatments made June 30th, 2020, 2 days before the harvest. And here we are now on the day of harvest, July 2nd. John and Aaron are cutting the sod, both with machine and the shovel, to get it to the desired length. These were 12-inch wide pieces that were 6 feet long. Immediately prior to rolling the sod up, we removed the Ethylblock treatment from the sealed foil pouch. It's activated by dipping this small pouch, it looks very much like a tea bag, in water and placing it in the sod itself and then rolling. In the center of each of the sod rolls, we installed plastic tubing, which was going to be used later on for ethylene sampling. Then we took each of those 8 treatments per individual rep, placed them on a pallet, and hauled them to the back of the Turfgrass Research Center and placed them underneath our rainout shelter in order to keep the effects of possible rain from the sod that was harvested. We also were looking for kind of a worst case scenario, hot and dry, and these stayed in place for 72 hours there. We inserted thermocouples into the center of each sod roll to monitor temperature, and Dr. Zhang came to the field and sampled ethylene immediately after harvest, then at 24, 48, and 72 hours. And these gas samples will eventually be analyzed in the lab using a gas chromatograph. On July 6th, we removed 2 pieces, 2 1-square-foot pieces of the center cut sod, and we transplanted them onto expanded metal frames that have been placed and prepared soil just down the hill from the rainout shelter. We did this in order to determine the rooting strength at 5 weeks after sod transplant. And here's the root strength testing that's taking place in the field on August the 10th. We use a push-pull gauge scale, which gives us an assessment of how much force is required to lift these expanded metal frames from the soil. Dr. Zhang also evaluated the sod squares for their visual quality at this time as well. Now we'll look at some of the data. This is turf quality on the left, and it ranged in a scale from 1 to 9, with 1 being dead, 9 being exceptional, and 6 being minimal acceptable. Here is our untreated control. You see the ethylene biosynthesis inhibitors going left to right, the x-axis. So anything that has the same letter associated with its mean is not significantly different from each other at a 95% confidence interval. Dr. Zhang has marked the 3 treatments which were significantly different from the untreated control. Those were ethyl block, the AVG plus ethyl block, and the SPE plus ethyl block combination. The 3-way combination was only slightly greater, and it was not statistically different. And even AVG plus SPE, SPE alone, and AVG, even though they were quite a bit larger, those differences were not statistically significant. So the trend was there, but the statistics did not bear out at a 95% confidence interval. And here's rooting strength. Again, low to high on the y-axis, so the higher the number, the greater the force required to lift the root frame from the soil. And again, control and left to right, the treatments in the same order. Once again, they have the same letter, they're not statistically different. Dr. Zhang has marked each of the significant treatments in green. So AVG alone was better than the untreated control, as was ethyl block and AVG plus SPE. Similarly, we saw the trends, once again, that these tended to be slightly higher, but they were not significantly different. And what's interesting is that that 3-way combination, again, tended to be on the low side, very comparable to the control, which is what we also saw in the turf quality. That'll be something that we've got to examine further in the future. So in summary, ethyl block alone or with AVG and SPE enhanced the recovery of the transplanted tall fescue sod in terms of its visual quality. Ethyl block, AVG, and AVG plus the spermidine treatment promoted the rooting of the transplanted sod. Ethylene concentration and the temperature data will be analyzed at a later date and presented at that point in time. We'd like to thank the Lawn Institute in particular for their financial support of this project, and all of our colleagues in the Virginia Tech School of Plant and Environmental Sciences for their assistance as well.